Hello, I am Maurice Cuny. I'm an economist from the Alberta Energy Regulator. In this presentation, we will present an overview of the Regulatory Development and Economic Model. We thank you for your time and interest in this presentation. This presentation explains the problem the proposed regulatory intervention is trying to solve, how the proposed regulatory intervention was arrived at, the costs of the proposed requirements, and some of the inputs, assumptions, and concepts used in the economic model. These types of analysis have always been a part of our internal decision-making processes, and we hope this presentation will help you better understand the draft requirements within Directive 60 and Directive 17. The Government of Alberta announced its Climate Leadership Plan on November 22, 2015. Under this plan, the government committed to reduce methane emissions from Alberta's upstream oil and gas industry by 45% by 2025, compared to 2014 levels. The requirements address the primary sources of methane emissions from Alberta's upstream oil and gas industry, fugitive emissions, and venting, including emissions from pneumatic devices, compressors, and glycol dehydrators. For further information on the draft requirements, please see the other video in this series, Technical Summary of the Draft Methane Reduction Requirements. This slide shows the types of regulatory approaches that could be employed by the AER to meet policy objectives. Requirements can be envisioned as a spectrum ranging from highly prescriptive requirements that provide limited scope for operators to meet their compliance obligations, to more outcome-based requirements that provide greater scope. Multi-stakeholder committees provided technical inputs and recommendations in the development and evaluation of the various regulatory approaches that were developed. In addition to source-specific requirements, an operator-specific reduction target was considered. With an operator-specific reduction target, we would allocate portions of the provincial reduction target to each operator in the province without imposing any site, process, or equipment-specific requirements. Operators could use their discretion to determine how exactly to achieve their portion of reductions. We would have to determine a systematic way to allocate reductions to operators that fairly reflects each operation's contributions and is flexible enough to reflect any assets that are transferred or changes in production that occur over a year. We would also need to establish a way to confirm that operators are making the required reductions and enforce on those operators not making their portion of the reductions. Those challenges made this scenario not feasible, so the focus shifted to developing requirements that focused on reductions by source type. We evaluated various regulatory interventions using the following design principles. Cost-effective. Targets, sources, operators, and activities that maximize emission reductions with the lowest cost. Adaptive. Enables the AER and operators to accommodate technical innovation, operational constraints, socioeconomic contexts, and policy changes. Operationally feasible. Integrates with operators' existing business models and processes. Transparent and credible. Demonstrates that performance objectives are met and governments are satisfied with the quality and rigor of requirements. Based on the analysis of various regulatory options, which were informed by multi-stakeholder committees, the AER developed scenarios for each source type. It's important to note that while the AER authored the draft requirements, the Government of Alberta set the policy direction, including decision on the various scenarios for the source types listed in this slide. While we did this exercise for every source type, here's an example of the various scenarios we explored for venting reductions. Option 1, setting different venting limits depending on the type of facility types, fluid produced, or sources of venting at the site. Option 2, using a decision tree to determine which facilities should restrict venting. Or Option 3, using a vent limit applied to the average venting from all of an operator's sites. In terms of cost effectiveness, Option 1 does not allow operators to use company-specific knowledge to maximize methane emissions at the lowest cost. Option 2 targets sources and operations to reduce the costs associated with methane reductions. And Option 3 allows operators to target the highest emitting sites and to use company-specific knowledge to maximize methane emissions at the lowest cost. When considering adaptability, specific limits can restrict an operator's ability to adapt if their operations, available technologies, or economic conditions change, whereas a decision tree could provide more flexibility if these factors are included and fleet averages allow operators to trade off emissions between their sites, which maximizes their ability to adapt to changes. From an operational feasibility perspective, under option 1, using a broadly applied limit reduces the administration costs. However, it may be technically or economically infeasible for some sites to meet the limits. Option 2, on the other hand, requires an assessment of each site, which can increase administration costs. Generally, decision trees better address circumstances where reductions are technically or economically infeasible and limits can be set accordingly. Under option 3, operators have incentives to make the highest feasible reductions to offset sites where reductions are infeasible. Monitoring and calculating the site averages, however, may increase administrative costs. Finally, when considering transparency and credibility, under option 1, a common limit is easier to communicate to stakeholders, whereas option 2 may be more difficult to communicate clearly. Option 3 is also more difficult to communicate clearly and may be perceived as less credible, as some sites may continue venting at higher rates because they are offset by lower venting sites. And now I'm going to speak about the economic model we used to develop the draft requirements. I'm on a team of 6 economists, and we worked closely with the AER team that developed the draft requirements with input from the stakeholder committees. The model we developed together was used to assess the impacts of the draft requirements. The first step we took was creating a business-as-usual scenario. The BAU serves as a basis of comparison with which to measure the impacts of the draft requirements. The economic model consists of several modules that are linked and interact to each other. This model is conceptually dynamic. Please see the diagram illustrating the interactions between the modules. The economics modules uses cash flow analysis to project oil and gas sector's investment decisions and future activities, as represented in the oil and gas activity module. As we know, future production of oil and gas would come from pre-existing as well as new sites. Any negative impacts on these operations can be captured by estimating shut-ins, reduced drilling forecasts, and foregone investments. The emission module consists of technical information on emissions from pre-existing and new sites. The emission targets are also defined in this module. In the requirements module, regulatory phrases and conditions are translated into formulas and quantifiable measures. Limits and thresholds are defined here, and emissions under various regulatory options are compared against targets. Changes in the technology module will inform the economic module via new or additional costs and inform the emissions module via updated emission factors. Once the BAU scenario was established, additional info was added to modify the forecast and cost as per draft requirements. This resulted in new, reduced emissions forecasts that were analyzed and compared to the base BAU. The goal within the Government of Alberta's Climate Leadership Plan is to reduce methane emissions by 45% by 2025, relative to 2014 levels. Methane emissions in 2014 are estimated to be 36.8 megatons of CO2 equivalents from all sources covered by the regulation. If we add no new methane regulations, emissions are estimated to reach a level of 29.2 megatons by 2025. This reflects the current market conditions and pace of investments. The AER's draft requirements are forecasted to reduce methane emissions to 19.9 megatons of CO2 equivalents by 2025, which achieves the 45% target. According to the AER economic model for the draft requirements, the direct cost to industry will be approximately $780 million from 2018 to 2025. This cost includes both capital and operating costs. The AER's mandate is to design draft requirements that meet and not exceed the 45% target in order to minimize cost to industry. While designing the requirements to meet exactly 45% is ideal, adjusting regulatory stringency is complex, and it is challenging to meet exactly 45%. As economists, we are always dealing with a reasonable margin of error because of factors such as uncertainty around the emission data, operator performance, and future market conditions. In the table above, you will see that the cost of the proposed AER regulations is broken down by emission source. Direct costs are the sum of the incremental capital and operating costs incurred by the industry as a result of the new draft requirements, beyond the BAU costs. These costs total about $780 million. To calculate cost, first consider the additional equipment or services needed by the industry to be compliant with the proposed draft regulations. By looking at the additional equipment and not current equipment, we are isolating for the regulation's cost. Note that the equipment may be different depending on the emission source. Next, find the cost to purchase the equipment or service. This is the capital cost. Then, find the cost to maintain this equipment. This is the operating cost. Then, determine the count of sites that would likely incur these costs. Generally, this will enable us to calculate the total cost to the industry as listed above. In the table above, you will see the estimated costs of the requirements to industry from 2018 to 2025, expressed in dollars per unit of production. This will be 20 cents per barrel of oil equivalent of conventional oil, 7 cents per barrel of oil equivalent of primary bitumen, and 2 cents per 1,000 standard cubic feet of natural gas. The marginal abatement cost is the average cost of reducing 1 ton of CO2 equivalent. The chart above visualizes the marginal abatement cost expressed in dollars per ton against the emissions abated by a methane emission source. The width of the bars represents how much that source contributes to total emissions abated. Because pneumatics and venting have some of the lowest marginal abatement costs, but some of the highest contributions in total emissions, the proposed requirements focus primarily on these sources. The AER is implementing new measurement requirements, and the data and modeling is expected to continuously improve. The AER will conduct a regulatory review by 2022 to ensure that the target is met. Based on our calculations and depending on commodity, the capital cost to comply with the draft requirements from 2018 to 2025 represent less than 1% of total forecasted capital expenditures under business as usual by industry. Here are a few benefits, though I note that this is not a comprehensive list that includes societal benefits. The requirements will increase gas conservation while reducing greenhouse gases, volatile organic compounds, and other hazardous air pollutants. Broader and more flexible outcomes-based requirements can allow for technological innovation. These regulations will create opportunities to enhance investment in innovation. Prescriptive requirements will also be subject to the regulatory review in 2022, where new abatement technologies may be evaluated as well. Finally, I'd like to reiterate that the AER is seeking public feedback on the draft requirements within Directive 60 and Directive 17. The draft directives can be found on aer.ca. We are piloting a new way of collecting feedback online. More information is on the methane reduction webpage on aer.ca. Thank you for your time and interest. If you have any questions, please contact us at methane.reduction@aer.ca.